we're live here from Strand Mountain Resort in Vermont, and we're tracking the weather. Currently 38 degrees at the base of the mountain. At the top it's at 3,800, so we're going up 2,000 feet. So we're going to be talking about ELR, elapsed rate cooling and adiabatic cooling as we go up there, and the mountain snow. You can see we're at the waffle cabin enjoying the snow. Currently 38 degrees down here, and it's raining at the top. It's snowing. It's 8 degrees cooler at the top. That cloud right there is producing snow at the top of the mountain. We're boarding the gondola. Okay, we're halfway up. We're about 3,000 feet up on elevation, and it's sleeting now. At the bottom it was 1,800 feet and it was raining, and we still have another 800 feet to go and it'll be snowing. You can see all the ice on the window right here. We'll be at the top shortly. Okay, we're at the top and it looks like a winter wonderland. Check this out, it's a blizzard. It definitely didn't look like this at the bottom. But look at all the snow on the tree. We're at the top of the mountain at 3,800 feet, and you can see currently 32 degrees and snow. You can see we're next to the Black Bear at Strand Mountain, Vermont.
Oh, like Blizzard X now, Alec, look.
Yeah. You can see the weather station here at Strand Mountain Resort. Check it out. It's a Blizzard X at the top of the mountain. 32 degrees and snowing. Here, and the reason the elapsed rate cooling is the presence of water in the atmosphere. The process of convection, water vapor contains latent heat of vaporization. As the air rises, it cools and becomes saturated and cannot hold a quantity of water vapor. The water vapor condenses, forming clouds, which you can see over there and over there. Over there, it's a whiteout condition. Go up every 3,000 feet, it goes down 5 degrees, and then going down 1,000 feet, it goes 5 degrees warmer as you go down. The visibility is really poor. Okay, we're going to be making the water cycle and also the 3 stages of matter. You can see we're going to start off with the solid, which is also ice, and then we're going to turn it into water. We're going to liquefy it as that cooks for a few minutes. Right here where the ice is a solid and it's turning into a liquid, which is turning to water, so it's melting and absorbing 80 calories. The heat that we could feel right here is the latent heat. The ice in this glass of water is a latent heat that we cannot see the energy of the ice melt, but it is released when it is frozen, and also it's causing conduction, which is from the boiling heat. I don't know if you could see this, but the hot chocolate from right over there producing conduction, because we have a metal object inside the warm object sending heat through the conduction through the metal. Maybe you gotta stir it up a little bit. Oh, you can see it now. You can see it's starting to form up right there, look. And when 10 calories of heat are absorbed by 1 gram of water, the molecules vibrate faster and the temperature increases faster. Steam on the spoon. Also, water forms hydrogen bonds and ice is less dense than a solid. And it's also from in the clouds. 2 clouds are made of ice crystals too, so we were dissolving and making precipitation from ice to water. And 1 calorie is the amount of energy required to raise the temperature of 1 gram of water at 1.8 degrees Fahrenheit. Okay, now we're going to take this water that we just melted from the ice cubes and we're going to put it in the humidifier. We're going to make it water vapor. Now we're going to be making it evaporate from the water to the vapor. Okay, now we're freezing the water to a solid and it's going to be releasing 80 calories of energy. Okay, here's the liquid or the water that is now frozen to a solid, which is ice now. So that stage is from the liquid to the ice is freezing it. Dry ice, it's like a negative 110 degrees. Very dangerous to touch, so you don't want to. It's carbon dioxide. It goes from sublimation. It goes from a solid to a gas. It doesn't turn to a liquid. Okay, you can see some of the water's boiling up still, and the ice turned into like a cloud or something, and now I put some food coloring. Check that out. Check out this cool condensation frost that I got left it on my car. I left the car out overnight. Look at this. This is pretty cool. You can see we had a hard freeze last night. Check that out. You can see the ice crystals. It kind of looks like ice or snow. Check that out. That's pretty cool right there. I'm geeking out. The ice that was on my car, it melted a little bit and it made dew on the car. It made because the temperature got below the humidity, which causes the dew point, and it's causing the water vapor also froze up, and then now it melted. It condensed. And right over here, the water droplets dried up, so it evaporated over here. On the windward side, right here, you can see you either get rain and thunderstorms and snow, and then on the leeward side, like in California, it's like a desert because the mountain blocks the thunderstorms, so they can't go back down on the leeward side of the mountain. Here we're going to show you the rain shadow effect. You can see the stream down there. It gets evaporated into the air and creates clouds and cooling, and it creates rain on the windward side. But on a sunny day, you'll see this mountain right over here. It's going to block the rain over on the leeward side. You can see we're on the landward side right over here. The evaporation, the moisture gets dry as it goes over the mountain, and you get warmer and sunnier sides on the landward side compared to on the windward side because the mountain blocks the moisture and the precipitation.